and are network protocol independent. So in OSPF v3, the router interface information can be spread across the multiple router LSAs. So the receivers can concatenate all the LSAs originated by a router when running the SPF calculation. Then moving on to the type 2, which is network LSAs. This describes the link state and cost information for all the routers attached to the network. And this is an integration of all the link state and cost information in the network. So only a designated router tracks this information and can generate the LSAs. And also the network LSAs have no address information, and this is also network protocol independent. Then type 3, which is inter-area prefix LSAs for ABRs. This advertises the internal networks to routers in other areas, which means that's why it gets the name inter-area. And this type 3 LSAs may represent a single network or a set of networks, and that can be summarized into one advertisement. Only the ABRs, which is the area border router, generate the summary LSAs. So in OSPF v3, the addresses for these LSAs are expressed as prefix length instead of the address and the mask. And the default route is expressed as a prefix with the length 0. This is about the type 3 LSA, which is the inter-area prefix LSAs for ABRs, area border routers. And moving on to the type 4 LSA, which is the inter-area router LSA for ASBR, autonomous system boundary routers. So this advertises the location of the ASBR. And now the routers that are trying to reach an external network use these advertisements to determine the best path to the next hop. So this ASBR, autonomous system boundary router, only helps to reach the external network. So those whichever packet that wants to go to external network, they'll be utilizing this type 4 LSAs. And this LSAs are being generated by the ABRs on behalf of the ASBR. And next type is type 5, which is autonomous system external LSAs. It redistributes the routes from another autonomous system, usually from a different routing protocol. In OSPF v3, the addresses for these LSAs are expressed as again the same thing, prefix length instead of the address and the mask. And the same way, the default route can be expressed as prefix with length 0. And moving on to the type 8 LSAs, which is the link LSAs. This have the local link flooding scope and are never flooded beyond the link with which they are associated. So the link LSAs provide the link local address of the router, and this is shared to all other routers attached to the link. And particularly, it informs the other routers attached to the link about the list of prefixes to associated with the link. And it allows the router to have a collection of the option bits to associate with the network LSAs. And the last one is the type 9, which is intra-area prefix LSAs. So the router can generate multiple intra-area prefix LSAs. So this can be for each router or transit network, each with a unique link state ID. And this link state ID for each intra-area prefix LSA describes the association to the router LSA. So these are the link state advertisement types which are utilized in the OSPF v3 protocol. Next, some more informations about the OSPF v3, which means the address prefix occurs in almost all the newly defined LSAs, which means just now we have seen in all the types the prefix is represented by three things, the prefix length, prefix options, and the address prefix. And yes, instead of the address and the mask, these three informations are being utilized. And what about the default route? This is expressed by the prefix with length 0. And particularly type 3 and type 9 LSAs carry all the